do our first example of area integrals using polar parameterization. As always, our goal is to reduce to calculus 1. Once we convert to parametric form, we're going to integrate over those curves. Integrate over those curves where one parameter varies, all the other parameters are fixed. So we're always doing a line integral, and a line integral is a calc 1 integral. So here we go. Integrating over a domain. dA indicates that the domain is flat, so my surface is flat. In this case, it's a region on the xy plane, so its equation form is z equals 0. I'll write it in framed axes. I think it's easier to see. There's my circle, and there's my line, and there's my region above the line. Rewrite it into polar coordinates. In the first equation, I can solve for r. In the second equation, I'll solve for theta. Arctan is inverse tan plus copies of pi. So my first theta, pi over 4, and then I'll add pi to it, 5 pi over 4. Now I'll fix theta and vary r. So I'm going to be integrating over this line. And then I'm going to add up those lines over theta for my double integral. Need to rewrite d in parametric form. X is our cosine theta. Y is our sine theta. Our equation z equals 0, which we don't write because it's understood. And our differential r dr d theta. We already pre-computed it, makes that handy. Replace x by its parameterization, replace y by its parameterization, replace dia by its parameterization. Integrate over our curve. So the inside integral is our line integral. We're integrating over the curve where theta is fixed and r varies. R just varies from 0 to 2. Then I sum those to get my region. Just like summing pages in a book gives me my volume. It's exactly the same thing. Clean up the algebra. So just simplification, collect my r's, collect my thetas. I'm doing the inside integral first. Theta is fixed, so cosine theta, sine theta is a constant, and I can pull it out. This integral in r has constant as its limits, and so the whole integral is just a constant. There's no theta terms in the integrand, no theta terms in the limits. It's a constant. I can pull it out. Calc 1 integral times a calc 1 integral. Call it done. If I wasn't comfortable doing this manipulation, or I wasn't clever, or didn't feel like being clever, it's okay. We'll just go ahead and compute it. Integral of r cubed, 1/4 r to the 4th. Cosine theta, sine theta, still inside, because I didn't want to pull it out. I wasn't sure. Plug in my limits. Lower limit 0, so I just have the upper limit. 1/4, 2 to the 4th. A constant. And now we'd be done. Just for completeness sake, let's go ahead and integrate it. U is sine, du is cosine, So it's a u squared over 2. 2 to the 4th over 4 is 4. 1/2 u squared, 1/2 sine squared. Sine 5 pi over 4 minus root 2 over 2. Sine pi over 4, square root 2 over 2. Everything's squared, so they're both positive, and they cancel. So our volume is 0. X times y was positive as many times as it was negative. 0 net volume.